The science behind rainbows. Rainbows are among the most beautiful sights in nature. After a rainstorm, a colorful arc can suddenly appear across the sky, capturing everyone's attention. For thousands of years, people believed rainbows were magical, messages from the gods, or even bridges connecting earth and heaven. Today, science gives a different explanation, one that's just as fascinating. A rainbow is created when sunlight interacts with tiny water droplets floating in the air. Although sunlight looks white, it actually contains all the colors of the visible spectrum. These colors are red, orange, yellow, green, blue, indigo, and violet. Under normal conditions, these colors travel together, making sunlight appear white. However, when sunlight enters a raindrop, something remarkable begins to happen. The first step is called refraction. As sunlight moves from the air into a water droplet, it slows down because water is denser than air. This change in speed causes the light to bend. The bending is small, but it is enough to begin separating the different colors hidden inside the white light. Next comes a process known as dispersion. Each color of light bends by a slightly different amount. Red light bends the least, while violet light bends the most. Because of this difference, the colors spread apart, creating the familiar sequence seen in a rainbow. After the light has separated into different colors, it reaches the back of the water droplet. Instead of passing straight through, much of the light reflects off the inside surface of the droplet. This internal reflection sends the light back toward the front of the droplet. As the light exits the droplet, it bends once more. This second refraction increases the separation between the colors even further. Finally, the colored light leaves the droplet and travels toward the observer's eyes. A single raindrop can only send one color of light to an observer at a time. However, during rainfall, millions of raindrops are suspended in the air. Each droplet sends a different color from a different position. Together, these countless droplets create the colorful arc recognized as a rainbow. One interesting question is why rainbows are curved instead of straight. The answer lies in the angles at which light leaves each raindrop. Red light reaches the observer at an angle of about 42 degrees, while violet light reaches the observer at about 40 degrees. Since droplets at these angles surround the observer in every direction, the rainbow is actually a complete circle. From the ground, the lower part of the circle is usually hidden below the horizon, making the rainbow appear as an arc. From an airplane or a high mountain, it is sometimes possible to see the entire circular rainbow. Another fascinating fact is that no two people ever see exactly the same rainbow. Every observer receives light from a unique collection of raindrops. Even someone standing only a few steps away is seeing light from different droplets, making each rainbow a unique experience. Sometimes, a second rainbow appears outside the first one. This is called a double rainbow. It forms when sunlight reflects twice inside each raindrop before leaving. Because of the extra reflection, the second rainbow is dimmer, whiter, and has its colors reversed, with red on the inside and violet on the outside. Rainbows are not limited to rainy weather. They can also appear in the mist of waterfalls, near fountains, in ocean spray, and even from the fine droplets produced by a garden sprinkler. As long as sunlight shines through tiny water droplets at the correct angle, a rainbow can form. Despite their beauty, rainbows cannot be touched or reached. They are not physical objects suspended in the sky. Instead, they are optical phenomena created by the interaction of sunlight, water droplets, and the observer's position. As the observer moves, the rainbow moves as well, always remaining at the same angle. Relative to the sun, what appears to be a simple arc of color is actually the result of precise laws of physics working together. Refraction bends the light, dispersion separates it into colors, internal reflection redirects it, and a second refraction sends those colors back toward the observer. Millions of tiny water droplets repeat this process at the same time, producing one of nature's most breathtaking displays. The next time a rainbow appears after the rain, it serves as a reminder that even the most magical-looking wonders can be explained by science, making them no less extraordinary. If you enjoyed learning about the science behind rainbows, make sure to like this video and subscribe for more amazing science facts and discoveries. Thanks for watching, and we'll see you in the next video.